We're going to start by taking notes in our journal. So the title of this, you can have your EQ on there, but also write this on the top line. Multiplication and exponents. Okay, so the first example we're going to do is 4 to the third power. We're going to expand that out. So 4 to the third power just means I have 4 threes. 4 times 4 times 4. Go ahead and find what that is with your calculator.
Equals 60.
Yep, 64. Four times 4 is 16. 16 times 4 is 64. Okay. Then the next one is going to be 4 times 4 squared. We're going to expand this one too. So I have a 4, so I write that first. 4 squared means 4 times 4. So I actually get, again, 3 fours, which means 4 times 4 times 4, which is 64. Yeah. So these are the same thing. So what I want to write is 4 to the third power is equal to 4 times 4 squared. They're the same. Okay, let's do the next one. 3 to the fifth. So I'm going to write 3 times 3 times 3 times 3 times 3. So 5 threes. 3's multiplied times itself 5 times. We can put that in the calculator. So do 3 raised to the fifth power. $243. Okay, the next one is 3 squared times 3 cubed. Cubed means to the third power. So we're going to expand this one just like we did the last one. So I need to write 2 threes and then 3 threes. How many threes did I end up with?
5.
Isn't that the same thing as the one right above it?
Yeah.
3 to the fifth power?
Yeah.
Okay. 243. Okay, these are the same. So 3 to the fifth equals 3 squared times 3 to the third. Okay, so now let's do another one. 16 to the 12th times 18. Oh, no, 16 to the 18th power. Okay, raise your hand if you want to write out.
Me?
16 12s and 12 16s and 18 16s. Well, I got one person. Well, we're not going to do it. Sorry to get your hopes up.
Are you serious? Oh,
We're not really going to do it. Because why would I want to write out 16 of these? I want to look for a shortcut. So, listen. The shortcut. Do you see a pattern here? On this and on this. 4 to the third equals 4 to the first power times 4 to the second power. What could be done to these exponents to get 4 to the third power?
Add it.
Add, yeah. So put a little plus sign there. Okay, is the other one the same way? 3 squared and 3 cubed to get to the fifth power?
Yeah.
What's 2 plus 3?
5.
5, yeah. That's our shortcut. So that's going to make this 16 to the 12 times 16 to the 8 easier on us. We're not going to have to write it out and expand it all. Instead, we can use the shortcut. Add those. 16 to the 12 plus 18.
30.
I don't like how I wrote that.
No.
Yeah, to the 30. 16 to the 30. Okay, so this is going to work whenever I have variables like x to the fifth times x to the seventh. Let's use the rule instead of writing out all the x's and then counting them up. X to the fifth times x to the seventh. We're going to add those exponents. 5 plus 7 makes 12. So 5 plus 7 makes it x to the 12. That makes it much simpler. So we're going to summarize this. Our rule. We are going to add exponents when you multiply like bases. So that is our rule. It's going to work every single time. It's our rule. It's also the shortcut. Okay, so that's multiplication and exponents. So now we are going to do division and exponents.
Good afternoon, Buffaloes. Teachers, please excuse this interruption. Hey,
Okay, so division and exponents is our next topic. So let's make a prediction. What do you think the rule will be when I replace this multiply with divide? What are we going to do to exponents when we divide like bases? What do you think the opposite is? Because multiply and divide are opposites. So what's the opposite of addition?
Subtraction.
Okay, so we're going to see if that is truly the case. So let's see, 2, nope, I want to go up one row. 2 to the 6 divided by 2. Put that in your calculator. 2 raised to the 6th power divided by 2. $32. All right, so we know the answer. Now we're going to write this problem differently. We're going to write it as 2 to the 6 over 2 because that's also division. So 2 to the 6 over 2. We're going to expand this one. So I'm going to write 2 6 times. 1, 2, 3, 4, 5, 6 over a 2. Okay, so the great thing about division like this, something over itself equals 1. So we're going to mark it out. And how many do I have left? 1, 2, 3, 4, 5, right? What is 2 to the 5th? Put that in your calculator. 2 raised to the 5th.
32.
And it equals 32. How are these the same? What's the exponent on this 2 right here? What's that exponent?
1.
Yeah. What's that exponent right there?
1.
1. What's 6 minus 1? 5. 2 to the 5th? Okay. So it's going to be the same thing. Let's do this one. 3 to the 7th over 3 to the 5th. We're going to expand them out again. 1, 2, 3, 4, 5, 6, and 7. Write your 7 threes. And your 5 threes. 1, 2, 3, 4, 5. And then simplify any like ones out. So top and bottom, they're going to simplify out when they're the same because it equals 1. 3 over 3 is 1. So I add 1 times 1 times 1 times 1 times 1. And what do I have left? 3 to the power of 2, which equals 9. Okay. Okay, so it works, right? Let's do it this way. 3 to the 7th divided by 3 to the 5th. The rule, according to what we think, because multiply and divide are opposites, so add and subtract are opposites, we're going to subtract these. So this is 3, 7 minus 5. 3 to the 7 minus 5. To get our exponents. What's our new exponent if the exponent is 7 minus 5?
2.
2.
3 squared.
3 squared, which equals 9. So these are the same again. All right, so we need to write this as a rule. So let's see. And then we're going to practice it. So x to the 10 divided by x to the 4. What do we do whenever we divide like bases? Subtract them. So 10 minus 4 is our exponent. X to the power of 6. So let's write our rule. So our rule for multiplying was add exponents when you multiply like bases.
So it would be subtract exponents when you divide like bases.
Yep. Subtract exponents when you divide like bases. Okay, so the notes are what we're going to look at next. So this is all the examples. Okay, so look at your notes. Product of powers. So the first one, we have this multiplying of the exponents, multiplying of our bases. We're going to add our exponents. So I'm going to write a little rule here. I am still recording. Add exponents whenever you're multiplying like bases. So that is the product of a power rule. The quotient rule is when we're dividing and we subtract the exponents. Okay, let's go to the inside. So the top rows are the multiplying. So when we multiply, we add our exponents. So let's do the first one together. X squared times x to the third. They have like bases of 5. So keep our like base. What's our base? What's our exponent now? 5, yeah. 5 to the 5th. Which, put it on your calculator to find out what it equals. $3,125. Okay. Okay, go ahead and do the next one. Add our exponents. We still have a base of 2, but our exponent is now 11. 2 to the 11th power. 2,048 when you put it in the calculator. 7 to the 4th times 7 squared. 7 to the what power? 6th power. Because we are adding. 7 to the 6th power is, put it in your calculator. 648, yeah. 117,648. Oh, it is 49, yeah. Sorry. Yeah. Okay. Now we're going to do with the variables. So x squared times x cubed. What's our exponent going to be? X to the 10 because we're adding. Good job. Look for our like bases. So I have a to the 14 plus 9.
24.
23. But we have not done anything with 7 and 2. What operation is happening between all these numbers, all the coefficients? We add exponents when we multiply, right? When we multiply like bases. So that means I'm actually going to multiply coefficients. Multiply coefficients. I'm going to abbreviate that. So the coefficients are the numbers out front of the variable. So 7 times 2, 14. Okay, next one. Looks like we got a lot going on here, but it's easier than you think. Let's look for all the same bases, like bases. So I'll start with x. X and then x 72. 70 what? Well, what's the exponent on just an x? 1. What do I do with my exponents? Add them. 73, yeah. Okay, now look for another like base. Well, I need to go kind of in alphabetical order. So I'm going to go y next. Does y have anything else? No, no like bases. What about z's? Yep. 4 and 28. 32. There we go. Yep, you got to add them. Okay, so now let's do the quotient. Okay, so what did we say about quotient? When we divide, what do we do to our exponents? Subtract them. So go ahead and do the first 3 that have the number bases. And put them in your calculator. We're going to check together here in about a minute. So subtract them. So 9 to the 7 times 9 to the 3rd is 9 to the 7 minus 3, 4. 2 to the 23 times 2 to the 8th. Subtract 23 by 8. 15. Put them in the calculator. Then 7 to the 14 over 7 to the 4th power. Subtract those. What do we get? 7 to the 10th power. Y'all check and see if y'all got the same numbers as me.
The third one's long.
3, 2, 7, 6, 8. 2 to the 15. 3, 2, 7, 6, 8. That's what I got.
I'm talking about on the third one.
282,475,249.
You know, I'm saying it's long. It's a long number. It's a long number, that's what I'm saying.
Where? Which number's wrong?
No, I didn't say it was wrong. I said it's long.
Oh, sorry, I couldn't hear. Okay, let's do the variable bases now. Subtract them. A squared, easy, right? Thank goodness that one came out small. All right, this one, x to the 14 divided by x to the 8th. X to the 6th. But then what do I do with my coefficients? Hold on, but what operation is this? We gotta divide. 6. Okay, then this fraction I want to simplify. So what is 4 divided by 2? 2. Okay. C9 over C12. That's like saying C9 minus 12. What is 9 minus 12?
3.
What is it?
3.
Negative 3. You got to keep that negative with it. Or what about D? 7 minus 4. 3. And then E. Yep. Okay, but remember yesterday I said you can't leave your answer in negatives. So the only one that's going to be going to a different location is that C to the negative 3. It's going to be C to the positive 3 on the denominator because you can't have any negative exponents. So everything else stays up top. And if I just put E, that means E to the first.